Hi, my name is Nir, and today we are doing a Beehive of AI Part 7. Okay, so as you see on the screen, I'm trying to um, install a Mac operating system so that um, we will have a way of installing the um, software to make a Macintosh version. Okay, we have Windows, we have Linux. Now I want to try to make Macintosh because many people in the United States from some unexplained reason use Macintosh. So uh, this will take 1 hour and 51 minutes. I hope it will work. And in the meantime, I will write the next chapters of the book. We wrote 5 chapters, and now we will write 5 more. Okay, so let's begin. Let me close the windows. I will try to lower. I hope you will not fall. Hold on. Is this better? I think it's a little bit better. Okay, never mind. It's mostly for me, and I don't think anybody real is watching. It's mostly for me. Okay, so do you want to proceed? Yes. 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 Okay, we close everything because it's getting cold. Okay. So, here's where we stand after the period, the vision after the period. The core here hasn't changed. Beehive of AI has a distributed platform that splits workload models across open and related computers. Workers on computer and models locally can log in or out freely and earn nectar credits. 65% local base, 30% green base, 5% platform. What changed is the business model and framework. Since running payments from Israel as a solo dev isn't viable, the whole project pivoted to open source on March 23rd. Instead of use my platform, the story is now here is how you build this business. The book became the centerpiece, not just documentation, but the guide for anyone to replicate and profit from this idea. Current state, all as of March 25th, software solid improving honeycomb of AI is working by QT GUI for all three roles. New workers Queen Beekeeper, full internet test passed, Cloudflare plus video SMS, cross machine lab tests passed on both Windows and Linux, 5 AI backend backend supported RAM and Studio RAM CPP and demo. Um, not sure what demo means, but never mind. Book completely rewritten from scratch, prologue plus chapters 1 to 5 out done and in the repo. Chapters 6 to 10 epilogue are planned but not yet written. No chapters 6 to 8 were removed as part of the rewrite. What exists now? Chapter title 1, 2, 3, 4, 5. Okay, not yet written. So we are on the same page. The software works. The first half of the book is rewritten to match the open source pivot, and now it's time to write the next chapters. Ready when you are. What chapters would you like to tackle? Okay. Okay, let's do the next chapter, chapter 6. Thank you so much. Okay, now make something to drink. Okay, so this. Okay. Yes. This is the Macintosh installation. It's now 1 hour and 51 minutes remaining. It's not real time, like sometimes it's in 10 minutes it makes 1 minute in the installation. Like it's slow. because it's running in emulation on one processor. I didn't connect the battery, sorry. Okay, I think it's on. Okay, yes, it's connected. So it's 95% battery and charging from here. Okay, so in the beginning of the game Doom 3, like there is an opening, and when you get to um, talk with your officer, like he says, you took your sweet time, Marine. So, so here Claude is taking his sweet time. Um, we have to wait. Okay, here it did not continue at all, like did not progress at all. 1 hour and 51 minutes. Oh, here I clicked on it and now it's about 12 minutes remaining. Okay, so it progressed a lot. It just didn't update the screen before I clicked on the inside the virtual machine. Okay, so it's 12 minutes. Cool. Let's check here. Okay. Here we don't have indication of how much time it will take, but usually it's not like more than 10 minutes. So we will wait. Here something changed. Okay, did the restart? Okay, let's see what's going on here. Okay, almost 10 minutes. So I hope it soon will finish. Okay, now it says about 28 minutes remaining. Okay, so half an hour. Okay. Here, I don't know if I can call this progress, but changed something. It's now doing a tool result something. Proceed. Okay, so he's cutting it into chunks and trying to read the whole book so far, even though he created the book, so I don't know why it takes him so long. Okay, so now he's writing the book about, I'm sorry, the chapter about the economics, about the money. Instead of show me the money, it's like show me the honey, how everyone else. Okay, I will walk around the apartment because I am bored. Okay, it's over. Now ending. Oh wait, he wants to write it. Wait, I want to read it first. Okay. Okay, chapter 6, show me the honey, how everyone else. Every system, every system that involves people doing things for other people eventually comes down to one question. Who gets paid and how much? It's such an American view of the world. Okay, and disgusting. Like nobody does anything for free. Okay, you can have the most elegant technology in the world, you can have the most beautiful metaphor, the most compelling vision, the smartest AI, but if the economics do not work, if the people involved do not feel fairly compensated for their effort, the system dies. It does not matter how clever it is, people need to eat. So let us talk about money. Not in vague hand waving terms, but in specific concrete detail. How does money enter the system? How does it flow? Who gets what? And why does the split make sense for everyone involved? By the end of this chapter, you will understand exactly how every participant in the Beehive earns and why the economics of this system are fundamentally different from anything else in the AI industry. Nectar, the currency of the hive. Before we talk about dollars and euros, let me introduce you to the internal currency of Beehive of AI, Nectar credits. Every transaction inside the marketplace happens in Nectar. When a beekeeper submits a job, they pay in Nectar. When a queen bee completes a job, she earns Nectar. When a worker B processes a task, the worker earns nectar. The platform takes its small share in nectar. Why not just use regular money directly? For the same reason that arcade tokens exist or that Uber does not hand cash to drivers after every trip. An internal currency simplifies everything. It lets the system handle thousands of tiny transactions per day without the cost and complexity of processing thousands of real money payments. It smoothes out the accounting. It makes the experience seamless. But Nectar is not plain money. It is directly convertible to real currency. You earn Nectar, and when you are ready, you cash it out into dollars, euros, shekels, yen, whatever your local currency is. Think of it like the credits on a freelancing platform. The work happens in credits, and the credits turn into real money whenever you want. For beekeepers, the process works in reverse. You deposit real money, receive nectar credits, and spend those credits on AI jobs. Simple. The exchange rate between nectar and real currency is straightforward and transparent. There are no hidden fees, no mysterious conversion rates, no fine print. One nectar credit has a clear value, and that value is visible to everyone at all times. The split 65-35. Now for the number that matters most. When a beekeeper pays for a job, that payment gets divided three ways. 65% goes to the worker bees, the computers that did the actual processing. The ones that received subtasks ran them through the local AI and sent the results back. Collectively received the largest share. 30% goes to the queen bee, the powerful computer that splits the job into smart subtasks, distributed them to workers, collected all the results, and combined them into one polished final product. 5% goes to the platform, Beehive of AI itself, the marketplace, the website, the infrastructure that makes all of this possible. Let me say those numbers again because they are important. 65, 35. If you have ever worked with any other platform, whether it is Uber, Fiverr, Airbnb, YouTube, or the App Store, those numbers might surprise you. Most platforms take 15% to 30% for themselves. Some take even more. Apple App Store takes 30%. YouTube takes 45% of ad revenue. Uber takes roughly 25%. Fiverr takes 20%. Beehive takes 5%. Why? Because the platform does not do the work. The platform does not run AI models. The platform does not own the computers. The platform does not split tasks or combine results. The platform provides the meeting place, the marketplace where beekeepers find hives and trust is made visible. That is an essential service and it deserves compensation, but it does not deserve the lion's share. The workers do the work. The queen provides the intelligence. They should get the money. It is that simple. Why 65% for the workers? You might wonder, why do the workers get more than the queen? The queen has more expensive hardware, takes more risk, and does the hardest AI work, the splitting and combining that determines the quality of the final product. So, all true, but consider the math. A queen bee serves an entire hive. When a job comes in with 200 subtasks, the queen splits it once and combines it once. That is 2 operations. The worker bees collectively process 200 subtasks. That is 200 operations. The queen does 2 hard things. The workers do 200 simpler things. But those 200 simpler things are what actually produce the result. Without the workers, the queen has nothing to combine. Without 200 computers churning through 200 subtasks, the job does not get done. And here is the other side of the map. The queen's 30% comes from the entire job. Every subtask processed by every worker contributes to the queen's 30%. So even though the queen's percentage is smaller than the workers' collective 65%, the queen earns her 30% on every single job that flows through her hive. Let me make this concrete with an example. A beekeeper submits a job worth 1,000 nectar credits. The split, workers collectively receive 650 nectar, 65%. Queen receives 300 nectar, 30%. Platform receives 50 nectar, 5%. Now, if the queen's hive has 50 active worker bees and each one processed an equal share of the subtasks, each individual worker earns 13 nectar from this job. The queen earns 300 nectar. The queen earns more than 20 times what any single worker earns, which makes sense because the queen invested more, risks more, and provides the intelligence that makes the whole operation possible. But the workers collectively still earn more than the queen because there are 50 of them and they did the bulk of the processing. The system respects the collective effort of the many while rewarding the specialized contribution of the one. This balance is what keeps everyone motivated. Workers feel their contribution is valued, queens feel their investment is rewarded, nobody feels exploited. And that is the foundation of a sustainable system. How the money actually flows. Let me walk you through a complete transaction step by step so you can see exactly how nectar moves through the system. Step 1. The beekeeper funds their account. A small business owner deposits $100 into their Beehive of AI account. They receive nectar credits equivalent to $100. Step 2. The beekeeper submits a job. They submit a task, say, analyze 200 customer reviews, and the system calculates a price based on the size and complexity of the work. Let us say this job costs 500 nectar. The nectar is held in escrow. I don't know what escrow means, but let's see. A bond deed document in custody of okay, like a trustee. Okay. The 500 nectar is deducted from the beekeeper's account, but not immediately paid out. It is held by the platform until the job is complete. This protects both sides. The beekeeper's money is safe if the job fails, and the workers are guaranteed payment if the job succeeds. Step 4. The job is completed. The queen splits the work. The workers process it, the queen combines the results, and the beekeeper receives the honey. Step 5. The beekeeper approves the result. After reviewing the work and optionally rating it, the payment is released from a score. Step 6. The split happens automatically. The 500 nectar is divided. 325 nectar goes to the worker bees, split among all workers distributed proportional to how many subtasks each one possessed. 150 nectar goes to the queen bee, 25 nectar goes to the platform. Everyone can cash out. Workers and Queens can convert their nectar into real money whenever they choose. The money shows up in their bank account or payment service. The entire process from submission to payment is automatic, no invoices, no negotiations, no please pay within 30 days. The system handles everything. You do the work, you get paid, period. What determines the price of a job? You might be wondering who decides how much a job costs. If there is there a fixed price list? Does the beekeeper choose? Does the queen? The answer is the marketplace decides. Here is how it works. The system calculates a base price for each job based on its size, primarily how many subtasks it will generate and how complex each one is. A job that generates 30 subtasks costs less than one that guarantees 300. One that generates 300. A job that requires the AI to write creative content might cost more than one that requires simple data extraction, because creative work takes more processing power and time. But this base price is just a starting point. Different queen bees can set different pricing for their hives based on their capabilities and reputation. A queen with top-tier hardware, a flawless reputation, and a 100 reliable workers might charge a premium, and beekeepers will happily pay it because they know the results will be excellent. A newer queen, still building her reputation, might offer lower prices to attract her first customers. This is supply and demand, the same force that sets prices in every marketplace in the world. When there are many hives available and few jobs, prices drop, good for beekeepers. When there are many jobs and few hives, prices rise, good for queens and workers. The marketplace finds its own balance naturally without anyone setting prices from the top. For beekeepers, this means you always have options. You can choose the premium hive with a stellar reputation, or you can choose the affordable hive that is still perfectly good for your needs. It is exactly like choosing between a 5-star restaurant and a good neighborhood bistro. Both will feed you, but the experience and the price are different. Real-world earnings. What can you actually expect? What can you actually expect? I promised this book would be honest, and I'm going to keep that promise here. Let me give you realistic expectations for each role. Worker bees. Your earnings as a worker bee depend on 3 things. How powerful your computer is, how many hours per day it is available, and how much demand there is on the network. A typical home computer, a decent laptop or desktop from the last few years, can process a certain number of tasks per day. A computer with a good graphics card processes more. A powerful gaming machine processes even more. I'm not going to give you a specific dollar amount because the system is new and the marketplace has not yet established stable pricing. What I can tell you is the honest framing. Think of worker bee earnings as bonus money. It is your computer doing work it was not doing before, earning money that did not exist before. If it covers your monthly electricity bill, that is a win. If it covers your streaming subscriptions, even better. If the network grows and demand increases, those earnings grow with it. The beauty of being a worker bee is that your downside is essentially zero. You are not spending money. You are not taking a risk. Your computer was idle. Now it is earning. Whatever that amount is, it is more than the nothing you had before. Queen bees. This is where the economics get more interesting and more complex. A queen bee has real costs. if you are running powerful hardware at home, 1 second, let's see what it's doing. Okay, so doing something but not telling us how much time it will take. Okay, but it's another thing. We moved on to the next phase. Okay. A queen bee has, I'm sorry, okay, queen bees. This is where the economics get more interesting and more complex. A queen bee has real costs. If you are running powerful hardware at home, you paid for that hardware and you pay for the electricity. If you are renting a cloud GPU server, you are paying by the hour. Your earnings need to exceed your costs or you are losing money. The good news is that the 30% share is designed to make this viable. A queen who manages her hive well, who keeps her hardware costs reasonable, who curates good workers, who builds a strong reputation that attracts a steady flow of jobs, can run a genuinely profitable operation. The key skill of a successful bee is not technical wizardry. 1 second. Okay, select your country, Israel. Continue. Okay, transfer your data to this Mac. No. Written and spoken languages to follow. Accessibility, no. Data and privacy, okay. Create a Mac account. The password you create here will be used to log into this Mac. It will turn you to the side so you will not see the password. Sorry. Sign total account. No. Okay. So now it says welcome to Mac. See? Okay, so it will not be exactly like a professional photography. It's like it's me at home. Welcome to Mac. Continue. Okay, so like this is the main screen. I would think there would be some wallpaper, but there isn't. Change wallpaper. Square sunrise. Okay, it's supposed to show this, but it doesn't show. Let's choose another one. Oh, it's downloading. It takes time to download. Okay, it's like a movie. Okay, like you see a small play icon. So it's like moving. Oh, this is the screensaver. So the wallpaper is this image. Okay, it's not clear to me what is it doing. Um, okay, I'm not sure why we don't see a wallpaper, but it's not important. Okay, so I click wallpaper to show desktop. Okay, like here's two modes. One is this, and another click is this, and back and forth, back and forth. I'm not sure why it doesn't show the wallpaper. Let's try to download the photo. Safari. Let's see. Okay, 9080. 1981, 1981, 1982. Okay, let's take this one. It's the first one that I like. Um, so click, save image to download, save image to photos, add to photos, use images desktop. Okay, let's see if we did this. Let's add this also to photos. Let's see the photos. Okay. I don't know how to operate this thing. Okay. So it worked. So we have a photo. So instead of fill screen, we do fit to screen. Okay, it's better than nothing. At least we have something nice to look at. And now we will ask Claude to make Claude code for us in this inside. Okay, so we will suspend, like pause this. Okay, and we will come back to this in a few minutes. Maybe not a few minutes. After we finish the book, we will try to make a Claude code inside. And then to code the Macintosh version. Okay, so Queen bees. This is where the economics get more interesting and more complex. The Queen bee has real costs. If you are running powerful hardware at home, you pay for that hardware and you pay for the electricity. If you are renting a cloud GPU server, you are paying by the hour. Your earnings need to exceed your costs or you are losing money. The good news is that the 30% is designed to make this viable. The queen who manages her hive well, who keeps her hardware costs reasonable, who curates good workers, who builds a strong reputation that attracts a steady flow of jobs, can run a genuinely profitable operation. The key skill of a successful queen bee is not technical wizardry, it is business sense. Knowing when to scale up your hardware because demand is growing. Knowing when to scale down because things are quiet. Knowing which jobs are worth taking and which are not. Knowing how to keep your costs below your revenue. This is in every meaningful sense running a small business. And like any small business, the people who pay attention to the numbers are the ones who succeed. Beekeepers. For beekeepers, the relevant number is not what you earn, it is what you save. Let us compare. If you use a major cloud AI service to process 200 customer reviews, you might pay anywhere from $10 to $50, depending on the service and the model you use. If you hire human workers to do the same analysis, you might pay several $100s or more. On Beehive of AI, the same job costs less than the cloud option because the overhead is fundamentally lower. There are no massive data centers to maintain, no cooling systems to run, no billion-dollar AI training costs to recover. The computers already exist. The electricity is already being paid for. The AI models are free and open source. The only costs are the small payments to the people whose machines did the work. For small businesses, startups, non-profits, researchers, and anyone else who needs AI processing but watches their budget carefully, this is the value proposition. Not just cheaper than hiring humans, which it obviously is, but cheaper than the cloud alternatives too. And in the private mode, the cost drops even further, essentially to zero, because the organization already owns the computers and pays for the electricity regardless. The private mode economics. Speaking of the private mode, let me spell out the economics here, because they are almost absurdly favorable. An organization considering the private mode already has the computers, already pays for the electricity, already pays for the internal network, already pays for the IT staff. All of those costs exist whether they use Beehive of AI or not. The only new costs are setup time. One IT person spends a few hours installing and configuring the software. This is a one-time cost. AI models, free, open source, downloaded once. Software, free, open source. Ongoing maintenance, minimal. The system mostly runs itself once configured. Now compare that to the alternatives. Option A, Cloud AI Service. The organization pays per query, every time, forever, and they send their data outside the building, which for many organizations is not an option at all. Option B, hire more people. The organization hires analysts, reviewers, researchers to do the work manually. Salaries, benefits, office space, management overhead. The costs are enormous and ongoing. Option C, build a private AI infrastructure. The organization buys a dedicated AI servers, hires AI engineers, builds and maintains a custom system. This costs hundreds of thousands or millions of dollars and takes months or years. Option D, use Beehive of AI in private mode. Install free software on existing computers. Download free AI models. One person, a few hours, done. The computers that were sitting idle at night and on weekends now process the organization's AI work. Total new cost, close to zero. For a hospital that needs to analyze 10,000 patient records, the choice is between spending six figures on consultants or cloud services, or spending nothing and letting their own idle computers do it overnight. For a law firm reviewing thousands of documents for a major case, the choice is between billing hundreds of hours of associate time or having the firm's own computer do the first pass in a fraction of the time for essentially free. For a government agency that cannot send data outside its walls under any circumstances, the private mode is not just the cheapest option, it might be the only option. The economics of the private mode are not just good, they are transformative. They turn computing power that organizations are already paying for and currently wasting into genuine business value. It is like discovering that the building you have been heating and lighting for years has a gold mine in the basement. Why 5% is enough for the platform? I want to address this directly because if you have any experience with technology platforms, the 5% platform fee probably raised your eyebrows. Most platforms charge much more because they are providing much more, or at least they claim to be. Uber provides the matching algorithm, the payment processing, the insurance, the support staff, the massive engineering team. Apple provides the App Store, the review process, the distribution, the billing system, the global infrastructure. These are expensive operations, and the companies argue that their 25 to 30% cut is justified. Beehive of AI is designed differently. The platform is lean by intention. It provides three essential services. One, the marketplace, the website where beekeepers find hives and submit logs. Two, and submit jobs. Two, the trust system, the reputation scores, the ratings, the identity verification. Three, the payment system, the Nectar accounting, the escrow, the cash out process. That is it. The platform does not run AI. It does not own computers. It does not process tasks. It does not store data. The heavy lifting, all of it, is done by the queens and workers on their own hardware. This means that the platform's operating costs are low. A website, some servers, basic infrastructure. Nothing compared to the billions that cloud AI companies spend on their data centers. And because the platform is open source, even those costs can be shared with the community. $5% covers the operating costs and leaves room for the platform to grow and improve. does not drain value from the people doing the actual work. That is by design. That is the philosophy. And honestly, if someone looked at this system and thought, I could run this marketplace better and charge only 3%, they could. The software is open source. The code is free. Anyone can set up a competing marketplace. That possibility, that competitive pressure, is what keeps the 5% honest. It is not 5% because I'm generous, though I like to think that I am. It is 5% because in an open source world, charging more would simply drive people to set up their own version. This is the beauty of open source. It does not just make the technology free, it makes the economics fair. The flywheel. Why the economics get better over time. There is a concept in business called a flywheel, a system where each part reinforces the others, creating momentum that builds over time. The Beehive of AI marketplace is a flywheel, and understanding it helps you see why the economics improve the more the system grows. Here is how the flywheel works. More beekeepers submit jobs. More work is available for hives. More queens set up hives to capture that work. More workers join those hives to earn money. More computing power is available. Jobs are processed faster and cheaper. More beekeepers are attracted by the speed and price. More jobs are submitted, and the cycle continues. At every turn of this flywheel, the system gets better for everyone. Beekeepers benefit because more hives mean more competition, which means better quality and lower prices. Queen bees benefit because more beekeepers mean more jobs, which means more revenue for their hives. Worker bees benefit because more queens and more jobs mean more tasks available, which means more earnings. The platform benefits because 5% of a large number is more than 30% of a tiny number. This is the same flywheel that powers every successful marketplace. Amazon got cheaper as more sellers joined, which attracted more buyers, which attracted more sellers. Uber got faster as more drivers joined, which attracted more riders, which attracted more drivers. The principle is universal. A marketplace that works for everyone attracts everyone, and the bigger it gets, the better it works. The early days of any marketplace are the hardest. There are few buyers, few sellers, and the flywheel turns slowly. But once it catches momentum, it accelerates. And in our case, the low barrier to entry, free software, existing computers, no technical expertise expertise for workers, means the flywheel can start turning faster than most marketplaces because the cost of participation is essentially zero. A note about fairness. I want to end this chapter with something that matters to me personally. When I designed the economics of this system, I had a choice. I could have designed it to maximize the platform's revenue, charge 25% like Uber. I could have designed it to favor the queens, give them 50% since they have the most expensive hardware. I could have designed it to favor the workers, give them 80% since they do the bulk of the processing. I chose 65, 35 because I believe it is fair, not perfect, no split ever is, but fair in the sense that each participant's share reflects their actual contribution and their actual costs. Workers contribute the most processing power collectively, they get the most collectively. Queens contribute the intelligence, take the risk, and invest in expensive hardware. they get a substantial share from every job, enough to run a profitable operation. The platform provides the essential meeting place and trust system. It gets enough to operate and improve, but not so much that it becomes the one getting rich while everyone else does the real work. I have seen too many platforms where when the company that built the marketplace ends up extracting most of the value, leaving the people who actually do the work fighting over scraps. Rideshare drivers who cannot afford car repairs, freelancers who lose a fifth of every payment to the platform, content creators who generate billions in ad revenue and see pennies. I did not want that for this system. The people whose computers do the work should get the money. The queen who provides the brain power should be rewarded. And the platform should be grateful for the privilege of connecting them. That is the philosophy behind the numbers. And because everything is open source, those numbers are not hidden in a corporate boardroom. They are visible to everyone. You can verify them. You can question them. And if the community ever decides a different split is fairer, the system can be changed. Open source does not just mean free code. It means honest economics. Now you know how the money works. You know the split, you know the flow, you know why the economics make sense for every participant. You have the complete picture, the technology, the roles, the marketplace, and the money. But you might be wondering, this all sounds great in theory, but can I actually set this up? Is it really as simple as you keep saying? Yes, it is. And in the next chapter, I will prove it to you step by step from zero to a working beehive in plain language that anyone can follow. Okay, I think it's very good, yes. Okay, chapter 6 is written. Here is what it covers. Nectar credits, the internal currency, why it exists, how it converts to real money, the 65-35 split, workers get 65%, queen gets 30%, platform gets 5%, with a clear explanation of why. 3. Why 65% for workers, the math behind why collective effort gets the largest share with a concrete 1000 nectar example. 4. How money actually flows step by step from deposit to cash out, including the escrow system. 5. What determines pricing, supply and demand in the marketplace, queens setting competitive rates. 6. Real world earnings, honest expectations for each role, no false promises. 7. Private mode economics, the almost absurdly favorable case where existing hardware plus free software equals near zero cost compared to 4 alternatives. 8. Why 5% is enough? Lean platform design plus open source competitive pressure keeps it honest. 9. The flywheel, how growth makes the economics better for everyone over time. 10. A note about fairness, the philosophy behind the split contrasted with platforms that exploit their participants. It follows the same style as your other chapters, conversational, concrete examples, no jargon, both public and private modes covered, and bridges naturally from chapter 5's closing to chapter 7's setup guide. The file is at blah blah blah. Want me to push it to the GitHub repo, or would you like to review and adjust anything first? So It's in this. Okay. Yes. 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 the read to output might not be easy to read in the conversation. Let me paste it directly for Chapter 7 from 0 to Beehive. Anyone can set this up. I've made a lot of promises in this book. I told you that anyone can participate. I told you that you do not need technical skills. I told you that setting up your computer to earn money or setting up your organization to use its own idle machines for AI is something any person can do. Now I'm going to prove it. This chapter walks you through the entire setup from a computer that has nothing installed to a fully functioning Beehive. I'm going to do it in plain language with no assumed knowledge. If you ever installed a program on your computer, Spotify, Zoom, Chrome, anything, you can do this. And if you have never installed a program on, that is okay too. I will tell you what to click. Before we start, what you need. Let me set your expectations clearly. To participate as a worker bee earning money with your idle computer, you need 1. A computer, Windows, Mac or Linux, made in the last 5 or 6 years. That is it. 2. An internet connection. Any speed is fine. The system sends small amounts of data, no streaming videos. 3. About 30 minutes for the initial setup. After that, it runs itself. To participate as a beekeeper, submitting AI jobs, you need even less. 1. A web browser, any browser. Chrome, Firefox, Safari, Edge, they all work. 2. An account on the Beehive of AI website. That is literally it. There is no software to install. To set up a queen bee running a hive, you need more powerful hardware, a bigger AI model, and some understanding of costs. I will cover the queen setup later in this chapter, but honestly, most people should start as a worker bee and graduate to queen only when they understand the system well and are ready to invest. To set up the private mode for an organization, you need one person with basic IT skills and access to the organization's computers. I will walk through that too. Let us start with the role that 90% of readers will care about most, the worker bee. Setting up a working bee. This is the simplest part, and I am going to walk you through it as if we were sitting side by side at your desk. Step 1. Get an AI model running on your computer. Before your computer can do AI work, it needs an AI brain. Remember from chapter 3, there are free programs that let you run AI locally. The one I recommend for most people is called Olama. Here is how to install it. On Windows, open your web browser and go to olama.com. Click the download button. Run the installer. Just click next a few times, the same way you install any program. When it is done, Olama is running in the background. You will see a small llama icon in your system tray, the little icons in the bottom right corner of your screen. On Mac, open your web browser and go to olama.com. Click the download button. Open the downloaded file and drag Olama to your applications folder. Launch Olama. It appears as a small icon in your menu bar at the top of the screen. On Linux, open a terminal, the text command window, and type curl -fs capital S capital L https://olama.com/install.sh vertical line sh. Press enter. It installs itself. Done. Now you need to download an AI model. This is the brain, quote unquote, your computer will use. Open a terminal or command. On Windows, search for command prompt in the start menu and type Olama pull llama 3.2 3b. Press enter. Your computer will download the model. It is about 2 gigabytes, so it might take a few minutes depending on your internet speed. When it finishes, You have a fully functional AI brain on your computer. So, want to test it? Type Llama run Llama 3.2 colon 3b. Ask it anything. What is the capital of France? If it answers Paris, your AI is working. Press Ctrl plus D or type /by to exit. That is it. Step 1 is done. Your computer now has an AI brain. A note about model choices. The Llama 3.2 colon 3b model is small and fast, perfect for getting started. If your computer has a good graphics card with 8 or more gigabytes of memory, you can try a larger model like Llama 3.1 8 billion, which is smarter but slower on modest hardware. The beauty of this system is that you can change your model anytime. Start small, experiment later. What if you prefer a different AI program? Llama is my recommendation because it is the simplest, but the system works with several others too. LM Studio gives you a visual interface with windows and buttons. Nice if you do not like typing commands. Llama.cpp is a lightweight option that uses fewer resources. VLLM is the fastest option for powerful Linux machines. The honeycomb of AI software detects which one you have installed and works with it automatically. You do not need to learn multiple programs, just pick one. Step 2. Download and install Honeycomb of AI. Honeycomb is the software that turns your computer into a worker bee, or a queen bee, or a beekeeper, but we are setting up a worker bee right now. Go to the Honeycomb of AI page on GitHub, github.com/strulovitz/honeycomb of AI. You will see a big green button that says Code. Click it, and then click Download Zip. Save the zip file somewhere on your computer and extract it. Right-click, Extract All on Windows, or double-click on Mac. Inside the folder, you will find the program and all its files. If you are comfortable with the command line, you can also clone the repository. Git clone http://github.com/strulovitz/honeycombofai.git. Either way, you now have the software on your computer. Step 3. Install the requirements. The software needs a few supporting pieces to run. Open a terminal or command prompt, navigate to the Honeycomb of AI folder and type pip install -r requirements.txt. This installs the necessary pieces automatically. It takes about a minute. If you get an error that says pip is not recognized, you need to install Python first. Go to python.org, download the latest version, and during installation, make sure to check the box that says Add Python to Path. Then try the pip command again. Step 4. Launch the software. Now comes the moment of truth. You have two options for running Honeycomb of AI: a graphical interface with windows and buttons, or a text-based terminal interface. Both do exactly the same thing. Option A, the graphical interface, recommended for most people. Python blank GUI _main.py. A window opens. You see three cards: worker bee, queen bee, and beekeeper. Click worker bee. A dashboard appears showing your worker status, ready and waiting. Before you start, click the settings button, the gear icon. Here you can set the address of Beehive of AI server you want to connect to. Choose your AI backend. The software automatically detects if you have Llama, LM Studio, or others installed. Test your connection to make sure everything works. Click Test Connection if you see a green click test connection. If you see a green check mark, you are ready. Now click Start. Your computer is now a working bee. It connects to the hive, announces itself as available, and waits for tasks. When a task arrives, you will see it in the activity log on your dashboard. Your computer processes it, sends back the result, and waits for the next one. That is it. You are earning. Option B, the terminal interface. Python honeycomb.py --mode worker. Text scrolls across your screen, showing the worker connecting and waiting for tasks. When tasks arrive, you see them being processed in real time. It is less pretty but works exactly the same. Step 5. Walk away. This is the most important step and it is the easiest. Do nothing. Leave the software running. Go about your day. Go to work, watch a movie, sleep. Your computer handles everything. When tasks come in, it processes them. When there are no tasks, it waits quietly using almost no resources. You can check in anytime. The dashboard shows how many tasks you have processed, how much you have earned, and how long your computer has been working. But you do not have to check. The whole point is that this runs without you. Setting up as a beekeeper. If you want to submit AI jobs rather than process them, your setup is even simpler. There is no software to install at all. Step 1. Visit the website. Open your browser and go to the Beehive of AI website. The address depends on which marketplace you are using. If it is the main public marketplace, it will be at beehiveofai.com. If someone has set up their own marketplace, remember the software is open source, anyone can, they will give you their address. Step 2. Create an account. Click Sign Up. Enter your details. You will receive a verification code via text message to confirm you are a real person. Enter the code and your account is active. Step 3. Submit a job. Click Submit a new job. Describe what you need done in plain language, the way you would explain it to a smart assistant. Analyze these customer reviews and categorize them by sentiment. Write program descriptions for these 20 items. Summarize these research papers. Attach any supporting files or information. Choose a hive from the available options. Look at the reputation and ratings. Set your budget. Click Submit. Step 4. Wait briefly. Depending on the size of your job, results come back in seconds to minutes. You will get a notification when your job is complete. Download the results, review them, and rate the hive's work. Your rating helps other beekeepers choose good hives, and it helps good queens build their reputation. That is the entire bookkeeper experience. No software, no technical knowledge, just a browser and a task. Setting up as a queen bee. Now we get to the role that requires real investment, both in hardware and in understanding. If you are reading this section, you are probably the kind of person who sees opportunity and wants to build something. Good. But read carefully because the queen role has real costs, and understanding those costs is the difference between profit and loss. The hardware decision. As I explained in chapter 4, there are 3 tiers of queen hardware. Tier 1, a powerful home computer. A desktop with a high-end graphics card, or even better, two graphics cards. This lets you run a larger, smarter AI model that, than what fits in a single card. The cost is significant, but within reach for someone making a serious investment. Think of it as buying equipment for a small business, because that is exactly what it is. Tier 2, specialized AI hardware. Products like NVIDIA's DGX Spark. Compact devices designed specifically for running large AI models. These are a step up in both capability and cost, but they give you access to dramatically more powerful AI models, which means your Hive produces dramatically better results. Tier 3, cloud GPU servers. Renting powerful machines from providers like Runpod, Lambda, or similar services. You do not buy the hardware, you rent it by the hour. This gives you the most power but requires careful cost management. Remember my story from chapter 4 about the $127 surprise bill? That is what happens when you rent powerful hardware and forget to watch the meter. For a new queen, I recommend starting with Tier 1, your own powerful computer. It has no ongoing rental costs, so your only expenses are electricity and the initial hardware purchase. You can always scale up later. Setting up the Queen software. The Queen runs the same honeycomb of AI software as the Worker, just in a different mode. Install a powerful AI model. For a Queen, you want something bigger than what Workers are running. If your Workers are running Llama 3.23b, 3 billion parameters, your Queen should be running something like Llama 3.170b, 70 billion parameters, or even larger if your hardware can handle it. The Queen's AI is what splits jobs into smart subtasks and combines results into polished final products. The quality of that AI determines the quality of everything your Hive produces. Launch the software in Queen mode. Graphical interface, Python GUI _main.py. Then click the Queen Bee card. You will see the Queen Bee console, a dashboard showing the job board, subtask tracking, and activity log. Terminal, Python honeycomb.py --mode Queen. In the settings, configure your Queen to connect to the Beehive of AI marketplace. Register your Hive, set your pricing, and then the Queen software begins monitoring for incoming jobs. Building your Hive. A queen without workers is a queen without a kingdom. You need worker bees to join your Hive. In the public mode, workers can discover your Hive through the marketplace and request to join. You can accept or reject them based on their hardware capabilities and reliability. Over time, you build a team of workers you trust. The key to a successful Hive is curation. Accept workers with reliable hardware and good track records. Monitor quality. If worker consistency produces poor results, remove them and accept someone better. Your reputation depends on the quality of your entire Hive, not just your own AI. A single unreliable worker who produces bad results can drag down your ratings. Managing costs. If you are renting cloud hardware, Tier 3, managing costs is critical. Here are the rules. Know your hourly cost. If your GPU server costs $2 per hour, you need to earn more than $2 per hour to be profitable. Simple math, but many people forget to do it. Scale with demand. When jobs are flowing in steadily, keep your servers running. When things are quiet, shut them down. Never leave a server idling with no work to process. Start small. Rent the smallest GPU that can run your target AI model adequately. You can always upgrade later when you have steady income to justify it. Track everything. Keep a spreadsheet. Revenue in one column, costs in the other. If the second column is ever bigger than the first, for more than a day or two, something needs to change. Setting up the private mode for organizations. This is the section for IT managers, system administrators, or anyone tasked with setting up a distributed AI system inside an organization. The private mode is where Beehive of AI shines for organizations with sensitive data. Hospitals, law firms, banks, government agencies, and anyone else who cannot send data outside their walls. What you need? Computers. You already have them. The desktops sitting on every desk. The workstations in every department. Any modern computer can participate. A network. Your existing internal network is fine. The computers just need to be able to talk to each other, which they already can if they are on the same office network. One designated queen. Pick the most powerful computer available, ideally one with a good graphics card. This will be your queen bee, the one that splits and combines tasks. One person with basic one person with basic computers skills. This person does the initial setup. After that, the system runs itself. Step 1. Set up the website internally. The Beehive of AI website runs on your internal network, not on the public internet. Download the Beehive of AI code from GitHub, github.com/Beehive of AI, onto one computer. This will be your internal marketplace server. Follow the deployment guide, deploy.md, in the repository to get it running. The short version: install Python, install the dependencies, run the server. It takes about 15 minutes. Okay, 15 minutes. Once it is running, any computer on your internal network can access it by typing the server's address into a web browser. It looks and works exactly like the public marketplace, except it is only accessible from inside your building. Step 2. Install the AI model on every computer. This is the most time-consuming step, but it is simple and repetitive. On each computer that will participate as a worker, install Olama, or your preferred AI backend, and download the AI model. For a large organization, your IT person can create a simple script that does this automatically on every machine. Install Olama, pull the model, done. If you have 200 computers, the script runs on all 200. It takes a few minutes per machine, and they can all run simultaneously. Step 3. Install Honeycomb of AI on every computer. Same process. Download Honeycomb of AI, install the requirements, configure each machine to point at your internal Beehive of AI server. Again, a script can automate this for hundreds of machines. On the Queen machine, configure Honeycomb of AI in Queen mode with a more powerful AI model. On all the others, configure them as workers. Step 4. Start everything. Start the workers, start the Queen, and the system is live. Your internal departments can now submit AI jobs through the internal website, and the organization's own computers process them. The data never leaves the building. Not one byte goes to the internet. The AI models run locally on each machine. The results stay on the internal network. Complete privacy, complete compliance, complete control. Step 5. Ongoing operations. The beautiful thing about the private mode is that it needs almost no ongoing attention. The computers process tasks during idle hours, nights, weekends, lunch breaks. The software starts automatically when the machines are on and stops gracefully when someone needs to use the computer for their regular work. The IT person might check in once a week to make sure everything is running smoothly. Update the AI models occasionally when better ones become available. They are always free. Add new computers to the worker pool when the organization buys new machines. Remove old ones when they are retired. That is it. An organization's own AI processing network, running on hardware it already owns, processing data that never leaves the building, maintained by one person spending an hour a week. But what if I get stuck? Setup is straightforward, but I know that technology can sometimes be unpredictable. A command might not work on your specific computer. An error message might appear that you did not expect. Something might not click the first time. Here is what you do. Check the documentation. Both Honeycomb of AI and Beehive of AI have README files with detailed instructions, troubleshooting tips, and common solutions. Check the GitHub issues page. If someone else has had the same problem, the solution is probably already there. Ask for help. The project is open source and open source projects thrive on community. Post your question on the GitHub discussions page, describe what happens, and someone, maybe another user, ask for help. The project is open source and open source projects thrive on community. Post your question on the GitHub discussions page, describe what happened, and someone, maybe another user, maybe me, will help you figure it out. So, use an AI assistant. This might sound circular, but it is actually the most practical advice I can give. Copy the error message you are seeing, paste it into ChatGPT or Claude or any AI assistant and ask, what does this mean and how do I fix it? AI assistants are remarkably good at troubleshooting computer problems. After all, that is one of the things AI was made for. The point is, you are not alone. Even though this is a new project and the technologies it is built on, Python, Ollama, Flask, PyQt6 are used by, even though this is a new project, the technologies it is built on, Python, Ollama, Flask, PyQt6 are used by millions of people. Help is always available. The demo mode. Try before you fly. Maybe you are not ready to commit yet. Maybe you want to see the system in action before you install an AI model or connect to a real marketplace. This is completely reasonable. Honeycomb of AI has a demo mode built in. When you run the software in demo mode, it simulates the entire process without needing any AI model installed and without connecting to any server. The worker pretends to receive tasks and process them. The queen pretends to split and combine. The beekeeper pretends to submit and receive. It is a sandbox, a safe playground where you can explore the software, see how the interface works, understand the workflow, understand the flow, and decide which role interests you, without installing anything beyond the basic software itself. To try it, Python GUI _ main.py. In the settings, select Demo as your AI backend. No Ollama needed. No model download needed. Just click and explore. When you are ready for the real thing, switch to a real AI backend and connect to a real server. The transition is one settings change away. A real setup, start to finish. Let me paint a complete picture by following one person through the entire process. Maria is a graphic designer in Madrid. She has a decent desktop computer, nothing fancy, but it has a mid-range graphics card because she sometimes works with large image files. She reads this book, or at least the first few chapters, and she wants to try being a worker bee. Tuesday evening, 7 p.m., Maria goes to ollama.com and downloads Ollama. The installer takes 2 minutes. She opens a command prompt and types Ollama pull llama 3.2:3b. The download takes 4 minutes on her home internet. 7:10 p.m. She goes to github.com Strulovitz Honeycomb of AI and downloads the zip file. She extracts it to a documents folder. She opens a command prompt, navigates to the folder, and types pip install -r requirements.txt. It takes 90 seconds. 7:15 p.m. She types Python GUI _ main.py. The Honeycomb of AI window opens. She clicks Worker Bee. She goes into settings, enters the server address, and clicks Test Connection. Green checkmark. She clicks Start. 7:17 p.m. Maria's computer is now a worker bee. 17 minutes from 0 to earning. She goes to make dinner. While she is cooking, her computer processes 3 text analysis tasks. She does not notice. She does not need to. Wednesday morning, 8 a.m., before leaving for work, Maria glances at her dashboard. Her computer processed 14 tasks overnight. She earned a small amount of nectar. Not life-changing, but her computer was asleep, and it still earned money. She leaves for work. The computer keeps working. A week later, Maria checks her earnings dashboard. Her computer has processed several hundred tasks over the week, running mostly during the hours she was asleep or at her day job. The earnings are modest, even for a nice dinner out. Enough for a nice dinner out. She considers leaving her computer on on during the day while she is at work to increase her earnings. A month later, Maria has earned enough to cover her internet bill. She upgrades her AI model to a slightly larger one, her graphics card can handle it, and her tasks per hour increase. She tells her friend Carlos about the system. He sets up his gaming computer as a worker too. His machine is faster and earns more because his graphics card is more powerful. That is the worker bee journey, from curiosity to earning in 17 minutes. An organization, start to finish. Now let me show you the same journey but for an organization. A medium-sized law firm in Chicago has 300 computers, desktops on every lawyer's and paralegal's desk. The firm regularly handles document review cases where they need to analyze thousands of documents. Currently, they pay junior associates to read through documents manually at $200 per hour. A large case might require 2,000 hours of document reviews, that is $400,000. The firm's IT manager, David, reads this book. He sees the private mode and has an idea. Monday, 9 a.m., David downloads Beehive of AI and Honeycomb of AI from GitHub onto the firm's internal servers. He follows the deployment guide and has the internal website running by 10 a.m. 10 a.m. to 12 p.m., David writes a simple deployment script. It installs Olama and downloads the AI model on a target machine. He tests it on 3 computers in the IT office. It works. After lunch, David pushes the script to all 300 computers via the firm's standard software deployment system. Every organization has one. It is how they install updates on all machines. By 3 p.m., Olama and the AI model are installed on every machine in the building. 3 p.m. to 4 p.m., David installs Honeycomb of AI on the same 300 machines using the same deployment system. He configures the most powerful workstation in the server room as the queen. Everything points to the internal Beehive of AI website. Okay, internal Beehive of AI website. Not the one on the internet, the internal. Okay. 4:30 p.m., David starts the queen and the workers. The internal distributed AI network is alive. Total setup time, 1 working day. That evening, 6 p.m., everyone goes home. 300 computers sit idle. Sorry. David, okay. That evening, 6 p.m., everyone goes home. 300 computers sit idle on their desks, connected to the internal network, waiting for work. The next morning, a senior partner submits a test job through the internal website. Analyze these 50 sample documents and flag any unusual liability clauses. The queen splits the job into 50 subtasks. The worker computers, the same machines that lawyers use for email during the day, process the documents in minutes. The results come back organized, categorized, and remarkably thorough. The senior partner calls David. How much did this cost? Nothing, David says. The computers were already here. The software is free. The AI models are free. And the data? Never left the building, not one word. The partner is quiet for a moment. Then, can we do 2,000 documents? David smiles. We can do 20,000. What you have learned. Let me summarize what this chapter has shown me. 1. Worker bee setup takes about 15 to 20 minutes. Download Olama, pull a model, download Honeycomb of AI, install requirements, launch. Done. 2. Beekeeper setup takes about 2 minutes. Visit the website, create an account, verify your phone, submit a task, done. 3. Queen bee setup requires real investment in powerful hardware, in a large AI model, and in understanding your costs. But the software setup itself is no harder than the worker setup. The challenge is running a profitable operation, not installing software. 4. Private mode setup takes about a day for one IT person to configure for an entire organization. After that, it runs itself with minimal maintenance. 5. Demo mode lets you try everything without committing to anything. No AI model needed, no server connection needed, just explore and learn. 6. Help is always available. Documentation, community forums, GitHub issues, and AI assistants can all help you pass any obstacle. The technology works, the setup is simple. The barrier to entry is lower than almost any other way to earn money with your computer, because there is almost no barrier at all. In the next chapter, I will show you something even more convincing than instructions. Proof. Real tests on real computers over the real internet with real results. No, not hypothetical, not simulated. Actually done by me and documented so you can see it with your own eyes. That's the full chapter 7. What would you like me to change? Okay. So thank you so much. Okay, so we will do chapter 8. I will go to make the drill. chapter 7 is already pushed from earlier, that was a premature push. So all the 3 repos are up to date with both chapter 6 and 7. Now let me write chapter 8, the proof we actually did it. This, the proof we actually did it. This one draws on your real test result. So I have all the data from project status.md, writing it now, and I will show you before touching anything. Chapter 8, the proof. We actually did it. Anyone can make promises. Anyone can describe a beautiful system, draw diagrams, write a compelling story. So, the internet is full of projects that sound amazing and in a presentation, but have never actually been turned on. This is not one of those projects. In this chapter, I'm going to show you the real tests, actual experiments I ran on real computers across real networks with real AI processing, real tasks, and producing real results. Not simulations, not mockups, not here is what it would look like. Here is what it actually looked like. With dates, times, machine names, and results, you could verify yourself if you clone the code and ran it. I believe that proof is worth more than promises. So here is the proof. Test 1. The first part. 2 machines on a home network. Date, March 22nd, 2026. Location, my apartment in Haifa. Machines, a Windows 11 desktop and a Debian Linux desktop, both connected to the same home router. This was the moment of truth. I had built the software, written the code, tested individual pieces in isolation, but I had never run the complete system across 2 separate machines until this night. Here is what I set up. My desktop computer, Windows 11. Okay, and answer, yes, it can work. Okay, I've done the research, here's what I found. The answer, yes, it can work. Two macOS virtual machines on two different physical Windows hosts can absolutely talk to each other over your LAN. The key is using bridged networking mode in VMware. Here is why. In bridged mode, each macOS VM gets its own IP address from your router, e.g., for example, 10.0.0.x, just like a physical machine. From a network perspective, each VM appears as a separate device on your LAN. Your router doesn't know or care that they are virtual. So macOS VM on desktop, for example 10.0.0.50, can ping/connect to macOS VM on laptop, for example 10.0.0.51, just like your Windows and Linux machines talk to each other. Important setup tips. Use bridged mode, not NAT. NAT would hide the VM behind the host and prevent cross-host communication. Don't use automatic bridge. Go to VMware Edit Virtual Network Editor, change settings, select VMNet 0, change from automatic to your specific physical network adapter, Ethernet or Wi-Fi. The automatic setting is known to cause issues with macOS Sequoia specifically. macOS Firewall. You may need to disable or configure the macOS Firewall in system settings to allow incoming connections. Wi-Fi bridging can be flaky. If the laptop connects via Wi-Fi, the bridged networking may be unreliable. Wired Ethernet is more reliable for bridging. If you have issues on the laptop, this is likely one. Ollama class Cloud Code on macOS VM. Ollama requires macOS 14, Sonoma or later. So macOS Sequoia is compatible. Install via the DMG from ollama.com. However, Ollama uses GPU acceleration, and in a VM virtual machine, there is no GPU pass-through to macOS guests. So Ollama will run CPU only, which will be slow. It will still work, just much slower than on your real machines with RTX cards. Cloud Code supports macOS 13 Plus and installs via the native installer or homebrew. Supports and installs via the native installer or homebrew. Should work fine in the VM. My recommendation, yes, install VMware plus macOS on the laptop too. It is worth it because you can prove the full pipeline works on macOS, Worker plus Queen plus Beekeeper. Two macOS VMs talking cross-LAN proves cross-platform compatibility. This makes a fantastic addition to Chapter 8. We even tested it on Mac running in virtual machines and it worked. The CPU on the Ollama will be slow, but it will still process tasks, which actually proves the point that even modest hardware can participate. One caveat. Since there is no GPU in the VM, the AI processing will be significantly slower than on your real machines. But for proving the concept and for the book, that's actually fine. It shows the system works even on weaker hardware. Want me to help you get started setting up the macOS VM networking in bridged mode on your desktop first? Sources, all kinds of websites. Okay, so I will try to do the same thing on the laptop, and then I will come back and we will continue. Okay, so I'm going to the left. I made myself lunch, like egg with onions and one onion and cheese and um, like pastrami, and also a salad with tomatoes and cucumbers and cheese and olives. And also I installed on the laptop the same Macintosh that we installed here. And now we will try to connect them. But first I want on each Macintosh to have cloud code. was like a seed of olive. So, okay, so the other half that was left, we will put in the fridge for tomorrow. And I have another salad, like half of the salad I ate now and half I will eat tomorrow also. I have another bowl like this. Okay, so I'll put it in the fridge and in the sink and I'll come back. now. Okay, the topic is full. Now we have a Mac OS Sequoia here and also on the laptop, and we will try to do step by step what he said. Okay, use bridge mode not NAT. NAT would hide the VM behind the host and prevent cross-host communication. Okay, so I'm activating this and I'm shutting it down. Okay, how to shut it down? Maybe file exit. Maybe here. Okay, here. So on the Apple icon, we have shutdown. Can reopen Windows by logging back in. Shut. Okay. I don't know if it's completed the shutdown. Okay, now it's completed. Now I have my mouse. Okay. Okay, now it's completed. So it took like half a minute to complete. Removable devices. Following devices can be connected to this virtual machine using the status bar of choosing VM removable devices. Include okay, I don't want to do this, so okay. So what I do want to do is the steps here. Use bridged mode, not NAT. NAT would hide the VM behind the host and prevent cross-host communication. Network adapter, maybe. Okay, so I will ask him. Thank you. So now I can start inserting a 60 workstation. Make this inside this matrix side of it virtual machine and the device and host and that laptop physical. Okay, so I will ask him. connected directly to the physical network. Replicate physical network connection state. Important not to breach. Leave replicate unchecked. Not to check it, click OK. Okay. Now boot up the Mac OS. Inside Mac OS, go to System Settings Network. Okay, in the meantime, I will shut down the Mac OS on the other computer and do the same. So, okay, so the thing you see. Didn't do it. Okay. So we Go tap the virtual macOS virtual machine. Inside macOS, go to System Settings, Network. So this is probably System Settings. Network. Okay. And check that it got an IP address in your home network range. Should be 10.0.0. Something, like your other machines. Yes, 10.0.0.7. Now I'm trying to do the same with the laptop. 10.0.0.7, subnet mask 255.255.255.0. About 10.0.0.138. DNS server desktop is perfect, 10.0.0.7 is on your home line, but the laptop has a problem. The issue Desktop macOS VM 10007 correct on your home network. Laptop macOS VM 172.212.35.81 wrong. This is not your home address. The 172.21x6 address and MS HomeNet domain are a dead giveaway. The laptop's VMware is bridging to the wrong network adapter. It's connecting to Windows Virtual Adapter, probably Hyper-V or WSA, instead of your real physical network adapter. To fix on the laptop Windows host. Don't do this inside macOS. Do this on the laptop's Windows 11 host. Shut down the macOS VM on the laptop. In the VMware workstation, on this on the laptop Windows 11 host. Shut down the macOS VM on the laptop. In the VMware workstation, edit virtual network editor. Click change settings, need admin rights, find VMnet 0, the one that says bridge. Where it says bridge to automatic, change it from automatic to a real physical network adapter. It will be something like Intel Wi-Fi or Realtek Ethernet, the actual hardware adapter that connects your laptop to your home router. Do not pick anything that says Hyper-V, Ethernet, WSL or VMware. Click OK to apply, boot the macOS VM again, check the IP, it should now be 10.0.0.0 something. Can you tell me what adapter options you see in the drop-down on the laptop? Okay, now we'll go to the desktop and to the laptop and try to on the same network. We can talk to each other. Let's verify with a quick test. Inside desktop macOS VM Open Terminal, you can find it in applications, utilities terminal, or press Command space and type terminal and type ping. You should see replies coming back from the laptop macOS VM. If you do, you're golden and ready to start setting up Olama Cloud Code and Honeycomb of AI on both macOS. Can you try that ping? Yes, concept. Okay, so the applications utilities terminal. Applications. Utilities. Terminal. Okay. And then close this. And I will write what it told me. Ping. 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 Oh, I wrote pings. No, it's not good. I made a typo. So, now it is stuck because of my typo. Okay, we'll try Control C. Okay, we'll try Control Alt Delete. No, okay, we'll try to restart. anything that you do wrong, it gets stuck very easily because it's very slow. Because it's in a simulation with just one processor. For, for the Mac, I guess it's very little. You need to drag it in Mac, you need to drag it to the applications. I think we can go like this. Okay. So now go applications. Oh, it's on the desktop. Okay. So okay. Go applications. Hold on. Verify Golama. Golama is an app downloaded from the internet. Are you sure you want to open it? Yes, open. Okay. Password. Okay. Background items added. Golama added items that can run in the background. You can manage these in login items and extension. Okay, so I don't see anything happening in the foreground. Okay, now it's opening. Golama 3.2, column 3B. Let's check that I wrote it correctly. Golama 3.2, column 3B. I will close the window because it's getting late and dark. something and type hello, and then back. Kel minus fs lowercase and sl uppercase. https cloud.ai install.sh vertical line sh. Install sh. Let's try. Setting up cloud code. Okay, it's cool. Okay, installation complete. Now I will go to Safari and log in with my Gmail, so later I can use Gmail in Cloud. Okay. Gmail. Sign in. Now the password. Next. Okay. Would you like to request applications to use this Google account? Yes. Or maybe not now. Not now. So. Okay, let's say yes because otherwise we'll no, I don't Continue. No, I don't want this. No, so. Cut. Okay. So I'm closing this. I'm closing this. Okay. Now what I'm going to do also is to go into cloud code. Right. Cloud AI, sorry. Cloud AI. Continue with Google. Choose an account. Sign in. Okay, cool. So NS, it's me. Okay, now on cloud, it should open the browser window to authenticate, login with your Anthropic account, and let me know when you are in. CLAUDE. Login successful, press enter to continue. And, to type in the macOS cloud code is this one sentence. Please read https github usercontent.com /it's honeycomb of AI main briefing. so annoying. What does it want now? $17. 8 hours, 7 minutes. Okay, 7 minutes is better. 3 minutes, 2 minutes. will walk around the house. It says 11 minutes. Everything is very, very slow. Start the broadcast later. Sorry. Bye.